Hello and welcome to Ask Echometer. My name is Carrie Ann Taylor, and along with myself from Echometer, we have Gustavo Fernandez, who will be presenting today. Also Ken Skinner, Lynn Rowland, Tony Podio, and Dieter Becker. So there's an Ask Echometer webpage that's accessible from our Echometer homepage, echometer.com. And you can go there right now if you'd like and download the Session 15 PDF documentation bundle. So that contains a PDF of today's presentation, and right next to that you can click the link to download the TAM examples we'll look at today. If you don't already have the TAM software installed on your computer, you can download it from the software page on the website too. There's a link from the home page to that. So we try to respond quickly to session topic requests, and we really appreciate hearing from you, and we really like it when you let us know what information you're needing from us. Right now there are a lot of people new to the TAM software, and that means we need to take a step back and focus on the basics too. And so today's session is titled TAM Software Features for Liquid Level Analysis. So Gustavo, I'll go ahead and hand it over to you now.
Thank you, Carrie Ann. Yes, today's presentation, we're going to be talking about several features that are available in the TAM software to analyze fluid level shots specifically. And probably even we have some experienced users that are not aware of all the features that they have available when they are analyzing more difficult or problematic wells. So thinking on that and thinking on a lot of new TAM users, we have decided to put this presentation together and try to show different features or capabilities you have in the software and try to bring some examples on when is it necessary, when is it information or features useful. The TAM software, the last release that you have very likely installed in your computer, if you have it, is at 1.7.41. And you will see some slides in my presentation that were done with TAM 1.8, which is the next version that's going to be released soon. The major development on that 1.8 version will be the RAM support, the remote asset monitor. But pretty much all the liquid level features will remain the same. So this will be useful for this version or the next version if you installed it in your computer. The information that's going to be presented is also available in the document that you can reach from the TAM help. When you open the TAM software on the bottom left corner of your screen, you will have a help button, and here you have a liquid level features document. I have it open here, and this liquid level features document will explain with details most of the options that you have available to analyze a liquid level shot. And for this presentation specifically, we're going to be focused on liquid level analysis. There are several other modules in the software and other topics that we might cover in a future session. But on this one specifically, we're going to be focused on the main liquid level analysis window. And on the top of this window, we have some results and access to the liquid level history of that specific well. On the center point of the screen, we have the main plot with the acoustic trace. And on the bottom, we have several options to explore and see what those features are useful for. And so we're going to be checking on all that. And on the left-hand side of the screen, we also have a drawing, have the wellbore schematic that the software will first on the wellbore schematic itself will be drawn based on the information that we input, like tubing, casing information, perforations, rod string if it's a rod pump or a PCP well, and depending on the type of well, we have a different drawing, but also on that plot, we will have an update at the liquid level calculation, as we can see down here. We have some drawings showing the liquid level depth and the liquid distribution in the wellbore. To start on the analysis, we're not going to be talking today about the sensor setup, and there will be, for sure, when 1.8 version will be out and available, we will have another session talking about the new way to set up, or where you can access the sensor setup buttons. And we're not going to be talking about other modules like dynamometers, counterbalance effect, or plunger lift. On this presentation, we're also not considering to talk about the utilities options in the software, like to import, export data, and how to create a well file. All that is planned to cover in a future session when, again, 1.8 version is out. You see one button here says scheduler. That's one of the new options to support the RAM system. Okay, let's focus on all the different features we're going to be talking today. And this orange square that you're looking at are different options that you can access when analyzing a liquid level. And the idea of the presentation is to show when is it useful, what happens when you click on those buttons, and try to get a better understanding of how TAM software works or what has available for you. Let's talk first about the liquid level test tabs that we can see on the very top of the screen. So one of the things that we need to consider is all the liquid level tabs are related to the well name that we can see on the left, just above the liquid level, the wellbore schematic. If we can, I'm going to be switching a lot between the presentation and the TAM software because I want to show you examples kind of in real time on every topic we're going to be discussing. So this is the liquid level tabs, and they are arranged by date and time. So the tab farther to the right will be the most recent fluid level, and the pauses farther to the left will be the oldest fluid level. If we can remember, so the old users that used to have TWM installed, switching from one data set to another and a different date or well visit wasn't that easy to do. So you needed to click several times, but here is really handy. So you have all the liquid level tabs, and just by clicking there, you're switching and previewing the liquid level on that specific date and time. There are more options to see the liquid level options, and let's talk about the liquid level history. When we click on the liquid level history, we have a table that we may show or not some thumbnails. And this liquid level table is usually arranged by time, but you can actually sort this by almost any other, but usually you want to sort that by time or chronologically. Also, there are several columns shown with different type of information, which you can modify by clicking select columns. And like in this example, we have a tubing pressure that has no information. And the reason why we have the tubing pressure here is probably on the wireless equipment, when you may have installed a pressure transducer in the tubing, so you could be recording simultaneously tubing pressure and casing pressure, and that would be plot here. That's one example we cover. But we can remove this column if we don't decide that it's necessary there. Once you are okay with the table, you can also print a PDF report, and that PDF report will show pretty much the information on the table. And let me go and do that here. So if we click on the liquid level history, we may see this tubing column available. So we can click on select columns and modify that table. So we can probably switch off that casing column, which is not very useful in this well. And once we're happy with the information that is being plotted, we can just click on PDF and create PDF file. So that will be probably a quick liquid level report, which will have all the history of the liquid level reports. We have the liquid levels, and you can sort that table either by this will be the latest or the most recent liquid level, or you can just invert based on the time. So it's really handy. Okay, let's go back to the presentation. And now let's talk about the test information. So once you select the test you want to analyze, one option that you have in the software is clicking on test information or clicking on this field where you can input the comments. So when you click on edit, some information is related to the test, like what TAM version was used to acquire the data, or the software version. You might use an older version from TWM that you're importing the data into TAM. We'll tell you also which sensors were used for that data set collection. So if you click on the details button, you will have some information related specifically to that sensor. And this, we can see a drawing up here of the remote fire gas gun. It's a wireless remote fire gas gun. So the acoustic trace and the pressure data is acquired with the same sensor. So we don't have a separate pressure transducer data. So we have here the serial number of that gun. So we name it like this. It's a wireless equipment. And the acquisition rate is 1,000 hertz, and that's a default sample rate for an acoustic single shot flue level. That you may find some places in the software where you can change the acquisition rate, but that's usually for a dynamometer data set or for a plunger lift data. But the single shot flue levels are all at 1,000 hertz. Then in the wireless remote fire gas gun, we have a pressure transducer, and also the coefficients are here. But something probably you want to focus on is what was the zero offset for that test, and when was it, at what time? So compare that with the flue level shot. So we have a March the 12th, 2020. So the last time the zero offset was performed was the same day, just a few minutes before. So we're kind of confident on the zero offset was performed just before the shot. And let's see what else could we do on that. So if we click on test information, we can also input some data like comments, and comments are very useful in some specific wells, especially when you can shoot flue levels through tubing, through casing annulus. It's really useful when you input here if it was a casing shot and how much pressure you use in the gas gun for doing the shot, and any other relevant information that you consider may be useful when you're analyzing the flue level. Going back to the liquid level history, we could check a different type of sensors, and we have the gas gun, and in this well we have several measurements. I'm going to pick one measurement, and just by clicking there, you probably didn't see it on the back side. Once you click on the specific measurement, the software will direct you and show the information related to that picked shot. So let's focus on this WG, which is a remote fire gas gun, wired. So we have two different sensors. It's a wired. Sorry for that. Let's go back to that shot again. It's this here. So we're looking at a flue level shot acquired with a wired gas gun and a pressure transducer. So we can check the test information and again look at the coefficients and check the zero offset compared to the shot time. The next portion of the presentation is going to be focused on probably one of the major upgrades that TAM software has available is how to navigate the main plot, the main acoustic level, flue level shot. When we look at the acoustic trace, and we have now much better capabilities to zoom in and focus on different areas, filter the information, and let's talk about how this works. So we have a subplot or a navigation plot on the top of the screen, and here the main plot will be whatever is on the white area and the subplot on top. So we can adjust this by dragging the white area or changing the size of it in order to zoom in or out on the acoustic trace. So we can click and drag, and let's say we can change the size of it, and let's make it this big. And again, the white area is being plotted on the main plot, and we can focus on, let's say, the fluid level kick and try to better visualize the acoustic tracks with much better details. And on the screen itself, we can also do a right mouse click. When you do a right mouse click, the software gives you several options on what you want to do with that acoustic shot. So one option is to print the image, and you can just copy that and print that as an image. You can actually copy the data to a clipboard, and you can manipulate that and later on paste it in an Excel file and make a different fluid level shot plot. But all those points in the acoustic trace may be copied to a clipboard. Or you can just export the data, and that will be exported to let's say, an Excel file. Or you can add notes. By adding notes, I mean you can add a note specifically on a point of the acoustic trace. Like if you know what a kick is related to, you can make annotation, and that's very useful when you try to explain a fluid level shot to someone that's not that familiar. Or when you, by analyzing the liquid level and comparing that to the wellbore schematic, you find some portions of the well that you can highlight, or portions of the acoustic trace that might be useful for the analysis. So you can make notes on the acoustic trace itself. Like in this well here, you just do a right mouse click, the option will be add note, and you can type, in this case was a tubing anchor. I'm just going to say TAC, and if you see, you can move these comments anywhere you want. And if that's not the right position, you can move it or displace it anywhere just by dragging to this little point here. And or you can just delete it. So there are several functions on the right mouse click in the software. Let's keep moving. Now let's talk about how to change the scale. And the software has also several options to do that. And talking on how to navigate, we can use the scale plus or minus buttons to adjust the millivolt scale on the left side hand of your fluid level shot. Or you can just use your mouse pointer. So you can use your mouse wheel as a zoom in or out your acoustic trace, and I'm gonna do that right now. So you can click on minus or plus just to zoom in or out, or you can just, I'm gonna scroll with my mouse wheel. That might be very useful, or sometimes you receive a data which is kind of like this, very high. Instead of doing several clicks, you use your mouse wheel. Small things, but might be useful. Okay, now something else. On the main plot, you have two vertical lines on the beginning of the analysis. You may have more as you enable them, but at least you will have a shot vertical, a dashed blue line, and a liquid level line. If you're using a color count method, you will have a third line with a C, but we're going to cover that in a few minutes. So these two lines, you may move this line just by clicking and dragging them. If you see when we are on the plot, you can now use a left button or a right button, or you can also do use your mouse pointer, click on it, and drag it to your specific or desired kick. On the other hand, the software also has the previews and next kick buttons, and what it does is that the software will search for another kick that might potentially be a liquid level kick, or at least another portion of the trace that complies with the criteria of the software to be a candidate of a fluid level. So I'm going to click on the previews, and probably this little kick here it complies with the criteria to be a liquid level, the liquid level kick, and there's another kick we can't see, but I'm going to scale up or just do this here. So the software considers that this down kick here also complies with the liquid level criteria, which might be totally wrong. Okay, so let's see with more details, and that's pretty much the explanation. If you have the PDF presentation printed, you will have some, extra information there. But let's talk about the fine-tune options. We will see more details on how to select the liquid level, how to select the shot beginning. Before going there, we have some options on how to modify the acoustic trace when it is somehow difficult to identify the liquid level, or when there are some areas that we are not sure if there is actually a kick coming from that portion of the well, and that is the apply low pass filter. You can see how the acoustic trace plot change when you click on apply low pass filter. And we can have several examples, and when the apply low pass filter may be useful. And let's cover that low pass filter. And very common, like when you're shooting fluid levels in a gas lift well. This is very noisy. Sometimes you shoot a fluid level with a gas injection open, and that would be even noisier. Or just noisy wells that you need to kind of eliminate this high frequency noise to see the background of that trace. So let me go here into the examples. I'm going to grab one of the examples that we have seen in previous sessions. Like, let's talk about this fluid level shot. So we can see a different kind of kicks by applying. Again, I'm going to click on fine tune and apply low pass filter. When we do that, it's great for gas lift well when the gas lift mandrel kicks are much more clear under the view of an apply low pass filter. We may have several kicks that might be confusing when we are selecting the mandrels, but we can eliminate all that noise just by applying the low pass filter. And we're going to see another example where the low pass filter was very useful to analyze the liquid level after the presentation. Okay, talking about the shot beginning. So the software will also allow you to adjust the shot beginning. And let's say this is the shot beginning selected by the software. You can go into that window, either grab the vertical line and drag it to the correct point, or you can use the left and right buttons to move it, or you can just reset to see what the software was doing. So the software selected this down kick as the shot beginning. There is also a threshold voltage that can or should be used when the automatic selection of the shot is not correct. So the software did a wrong selection of the liquid level, then you can change the threshold voltage when you have a very noisy well, for example, so you can have the proper selection. And I have an example here, and this V11 well. So this shot was it's a fake shot, but it's kind of to reproduce this condition when the actual shot went off here, but there is a kick big enough, and I'm going to be zooming in. Now we know how to use this plot. Or so the shot beginning is not correct because the shot beginning is this one. So the software is doing a wrong job by selecting the liquid level based on the threshold voltage. So we go into the fine tunes, and you can click on shot beginning, and we'll tell the software, this is your selection. If I click on reset, it's not moving, and this area here is actually a zoom in of the shot area. So we'll click, and we can also expand or contract this window. We will change this to 200 millivolts. So I want the software to pick a noise from the shot that is actually bigger than this one. So we will change the threshold voltage into 200 or 300. And we'll try to reset and see if the software can actually find the correct liquid level. So now it did a good job. So we see the right shot selection from the software. And that's probably you won't need to use this feature very frequently unless you have very noisy wells, like a pumping and heating up, some couplings hitting on surface, something that creates a major noise, or some connection problems on cables sometimes create spikes that are not actually an echo from the well or a vibration, but also makes the software to confuse. Okay, let's keep going. And that's pretty much the explanation of the threshold voltage. And now let's talk about how the software works on the liquid level selection. And again, this is a selection from the software, or you have moved your liquid level selector by dragging it to the place, and where you're not sure if that's a correct selection. Probably no, you might be closer here. You can drag it to the proper place, or you can use the left or right hand buttons, or just click on reset. So the software will select automatically the key that it thinks is the most likely liquid level. Of course, it's your task to ensure that the software is doing the right job on selecting the liquid level, and we'll see some examples when the liquid level is actually wrong. I mean, it's wrongly selected by the software, so you need to modify that. And again, this plot here is a zoom in at the surrounding area of the liquid level shot. On this window, you can also even zoom in even more. If you click again fine tune, I click on liquid level, and that's a zoom in. And if this is not enough, I mean, this is a window you can customize, but you can actually, again, drag it and click and have a really close zoom in. And we're looking at here thousands of a second. Okay, this is explanation of that. And now let's talk about the details. The details, we have something that's gonna be, you gotta be careful on how to select these options, because the software will automatically change the calculation based on your selection. So if you click on implosion or explosion, if you pick the wrong pulse type, the software will invert the acoustic trace. Now, the acoustic trace will be, let's see an example here. If I click on fine tune, I'm sorry, on details, and then an explosion, look how the acoustic trace is inverted. It's kind of a mirror. So you don't want to do that, because the software will actually do the same. It will attempt to select the most likely liquid level, and the time to the liquid level has changed to 9.7 now, and was actually 9.6 at the beginning. So the software will select a totally different liquid level kick, and the analysis will be totally wrong. On the other hand, if we click on tubing or casing, the software will automatically change the calculations and adjust to the new shot path. Like right now, we have a blue arrow pointing the casing annulus, because that's the selection. If we click on tubing, most of the time you don't shoot a tubing liquid level in a rod pump, but let's say you have a gas well or a gas lift well, or a plunger lift well, or any type of well that you can shoot a tubing liquid level, you can have the proper selection. The software will change the calculation to adjust everything to the tubing shot. But we also have to select here what's a well state on the details. And assuming you're in the producing state, the software will have a button as an option that probably most of the time you won't modify, which is the producing bottle hole pressure worksheet. When you click here, you have two options to let the software to assume, which is the default in the software, 100% water below the tubing intake or below the pump intake. Or you can change that if you have a different value for oil and water. Or you can also change that software will by default calculate the liquid percentage in the annulus, and you may do that, and the liquid percentage below the pump, or you can change that information. Like if you wanna show something different, the liquid percentage below the tubing intake. But you can also have it in static fluid level shots. If we click on static fluid level shot, this button will change from static into producing. And this static bottle hole pressure worksheet was previously discussed in the other Ask Echometer session, like the static bottle hole pressure calculation and the shotting fluid levels. So we're now going to discuss detail here. Is a static bottle hole pressure where you can select a 16 producing fluid level shot, or you will manually entry a producing fluid level shot to correct the calculation of the static bottle hole pressure. And let's keep going. And now let's talk about the pressure buildup. On the bottom right-hand corner of your screen, there's a casing pressure buildup if you're doing a casing shot, or a tubing pressure buildup if you're doing a tubing shot. Anyways, it's a pressure buildup plot, and there is an expand button here that will show a bigger plot of what the software is doing on recording the pressure buildup, either in tubing or casing, depending on the shot path. And the software will use this information to estimate the liquid percentage in the annulus, for example, but we'll also calculate the gas flow in the annulus, and we'll show more details on what is the casing pressure, how much the pressure changed in that time that the pressure buildup was run. But something else you can do here is, if you're not happy with the selection of the software, because the software by default will match the last point, it won't do an average, it will be just a straight line from the beginning to the last point. And you want to see something like this, where most of the pressure points are on the straight line, so the slope is very good, it's representative. But if you're not happy with that, you can use the left or right hand buttons to change the point up to the software will calculate the pressure buildup and all the calculations related to that. Like if you click on the left hand button, then you will see how the selection moves to the previous uh, point, or if you click on the right, that will automatically adjust the calculation. If you see it slightly changed from 3.6 MCF to 3.7 MCF, but pretty much everywhere you put the point here will be very close or similar result. And that's really important. And unfortunately, we see many fluid levels when people doesn't actually realize um, how important it is to record the pressure to calculate or estimate the liquid percentage, and then having a good bottle hole pressure calculations. And some examples we can bring here is uh, even when you collect the data. I'm going to pick a pumping unit noise. This is a good example, and we're not discussing the fluid level now, but let's focus on the acoustic trace. If I click on the expand button at the pressure build up, we will see a straight lines is good enough. I mean, this is a very representative shot, and we have 3.5 minutes of data here. But if we look at the next shot, we'll see something really different. So we have a very flat line, and then suddenly the pressure points go all over the place. That's normal when people shoot the fluid level, record the data, but then during the pressure buildup, they disconnect the cables. That was a second shot, and they are ready to go to the next well. So when they do that, the software or the pressure transducer will read any crazy value, and then we'll have pressure points all over the place. And this is going to over 2,000, or well, that would be 2 million NCF, and that's of course not real. That's just because they disconnected the cable. This fluid, so if we just record the data and we ignore that, of course the liquid percentage calculated will be extremely low. This is more a gas well, so this is not true. So even if we have only this shot, we can save this shot and bring this point back to a normal place. Or if we actually do two fluid level shots, we would probably use the first fluid level that has a better pressure buildup. Okay, let's keep going. This is the explanation on how to use these buttons. And now let's go into annotations. Annotations have several options in there that if you're not too familiar with the software, you might wonder, hey, what all these options are. So let's check on probably one of the best features. This I like it a lot, which is the wellbore overlay. I think it's selected by default in the software. And what the wellbore overlay will do is it will take this uh, wellbore schematic drawing and we'll plot that on the acoustic trace based on the acoustic velocity calculated. So it will show. We click on overlay. It will plot the wellbore schematic on the acoustic trace, and then you have an opacity cursor that you can, or slider that you can move to the right to make it darker or to the left, and this is how it works. Let me go back to the V11, which I don't have a wellbore schematic is plotted there, so it's overlaid. If I click on annotations and then it is selected right now, and I can make it darker, probably not too dark so you won't see the acoustic trace, but you can adjust that to your convenience. And we have several wells that the wellbore schematic helps you a lot on the analysis, helps you to avoid mistakes, helps you to avoid selecting the liquid level below the pump intake, for example. And let's see one of the common wells, like on the gas lift well. When you are using a wellbore overlay on a gas lift well, you can refer these kicks to the proper manual. So these kicks are not matching pretty well right now because the acoustic velocity is the average. But on different type of wells, I'm going to bring another example like this reduction liner. This is a very good example. And we can see a wellbore overlay on different configuration. We have a tubing change in diameter. We have a casing change. We have a tubing anchor, the pumps in depth preparations, and that becomes very useful when you have multiple kicks. When you have fluid levels close to the pump, when you have fluid levels below the perforations, or when multiple kicks are present, you want or you need to explain what those kicks are from, or then you can overlay the wellbore schematic. And another option that you may enable is liquid level warnings, and that's useful when that helps you to avoid mistakes, to avoid errors on the analysis. And I just put the liquid level marker below the pump intake, and when you do that and click on liquid level warning, the software will tell you, hey, the liquid level is below the end of the wellbore. That's not possible. The liquid level will be below. It's impossible that the liquid level could be below the end of the wellbore. So other option that we have is folded trays. So folded trays is probably a common practice on people who uses strip chart paper fluid level devices, where they have the fluid level shot printed on a strip chart, and when they have multiple kicks, they usually fold the paper to see if that acoustic tray matches. Like in this example here, we have a, a down kick, and an up kick. For the people who's familiar with liquid level analysis on uh, wells where the liner top is exposed, we can apply the fold trace button in order to bring all the acoustic trace below the liquid level line that will be folded up, that will appear like a red line, and to see if this upper kick will match to the down kick. So this is a normal behavior for the top aligner. And if it matches, you can confirm that this kick here is actually a reflect from or an echo from the top aligner. Another uses is when you have liquid levels that are deep, like you have only one kick from the liquid level at 9 seconds, and then you have another kick at 18 seconds, and then you fold the trays at 9 seconds, or you fold the paper, and the 18 seconds key will match to the 0 line, which is just a double time. Okay, and the depth reference line, that's very useful also when you have different kicks and you're trying to explain kicks on the acoustic trays that may belong to a wellbore condition. And when you apply the depth reference line, that will plot on the acoustic trace a red line, and you gotta be careful. Sometimes it might be hidden on the gray area that you're not looking at the main plot, so you want to search for the DR for the depth reference line on the subplot here. So this one is being plotted where we can see it, and it will bring a time and distance related to that point. You can grab that line and drag it to a different position, and that will be also plotted on the left hand side on the wellbore schematic. So if we see here, the depth reference line has a 5595 feet, and that's exactly what we see here on the plot. And again, I'm going to click on Annotations, Depth Reference Line, and I will drag this to a different point, and that will appear plotted on the acoustic trace, on the wellbore diagram. Let's keep on moving on the annotation options. As you see, it's a lot of options to explore. So another option that has been extremely useful and much easier to do nowadays with TAM, and when I say much easier to do, is because I'm comparing how we analyze fluid level shots with how we used to do it with TAM software. So it's a major improvement to have the capability to overlay acoustic shots. And if we click on the previous shots, this will bring, it's pretty much the table that we saw before, but it will tell you how many shots you have available to overlay. So every single shot that has been recorded to that well will be available to overlay. And you can see like you have on-off buttons on the left. So you click there and you turn on the fluid level shots that you want to overlay for that specific shot you're looking at. So you click on these two fluid levels. That's all I will use for the example. And what the software is doing right now on the background, we can't see it, but we have some more options that we will explore in a minute. On this plot, once we can see the trace, we can come back here and spread or put those fluid levels apart and swap the order, align them differently, or just show the distance to every liquid level depth. That's actually is a number right here, will be on the plot. But let's see how that looks. So once we overlay the shots, we can compare those fluid level shots. And I was talking about how to use the other options in the plot, and you can actually plot a maximum of 5 acoustic traces on top of the one you're analyzing, and that's usually a lot to digest. But on the previous shots, if you attempt to overlay more than 5, the software will have a pop-up window saying, hey, you can only overlay a maximum of 5 acoustic traces. And these on-off buttons are there to switch on and off, or what acoustic trace will be displayed. You have a spread apart or put closer those fluid level shots, and that will be based on your plot size or your screen size, and maybe you will need a bigger spread out to better understand. You have a clear all button, and I'm gonna cover one example in a few minutes where you can just unselect all the turn on acoustic traces. You can swap the order, so this will just invert the way the acoustic traces are plotted. And you can show the liquid level distance, and that will be a number next to the LL label on the vertical line, selecting the liquid level for that specific shot. And you can align those shots based on the depth or the time. And this is important because when you don't know actually when you haven't analyzed the well good enough to know the acoustic velocity, if you haven't used any specific method to come with an acoustic velocity, you better use the time at the beginning to know if you have repeated shots. So you're doing several shots on a day, and you want to see if one specific kick is repeating on those wells. So I'm going to bring one example uh, just to show how useful the overlaying part is. So let's talk about this flue level shot for a second. And yeah, this is kind of difficult to know. There are multiple kicks. It's a very dirty liquid level shots, and I'll be using some of the things that we have learned today, like scale down. Well, now I'm plotting pretty much all the area. I'm not sure the software is selecting correctly here at almost 19 seconds. I'm going to check the previous shot. And this is very noisy too. So we can see the full trace. It's a lot of spikes. It's hard to know where these spikes are actually the liquid level. And I'm going to check another shot. And if we zoom in and we plot all the shots, wow, that's kind of difficult to pick from this many kicks. And this is when overlaying the traces comes useful. And what I'm going to do is I'm going to bring this down a little bit. So I will decrease the scale. And I'm going to overlay these other flue level shots on here to see what kicks are actually repeating these shots. And whatever is not repeating, we know it's not an echo from the well. Because these were consecutive shots, like 3 minutes apart. So we see 12:55, 12:58, and 1:01. So it's just 3 minutes apart, shot after shot. But there is not enough time to push the liquid level, move it dramatically, and there is anything that is not repeating on those 3 shots is not actually coming from the well. That's probably an approach you want to do. So let's click on annotations. Let's click on previous shots, and we'll have a table with all the shots available. On this one, we have only 3 shots. So I'm going to turn them on, and I will probably need to, you may scale up or down, and you can resize this. So you can play with that until you feel comfortable with the data you're looking at. So we'll turn on these flue level shots. There is one button that I haven't talked about yet, and this is expand button. If you need more details on the main screen, you may click here, and that will expand the flue level window or the main plot so you can work better on it. And I'm going to click on annotations, previous shots, and I'm going to spread this a little bit more. Just like that. Okay, so on this big kick, so probably I will do something different this time. But at a glance, you might see a liquid level that's or a kick, a down kick that is repeating shot after shot. So if we see this up kick here, it's not repeating over here, and I'm going to use an annotation, a depth reference line, so we're familiar with the point I'm talking about. So this kick here in the blue line is not repeating on the black or I will say this is a green trace. So the black up kick is not there, it's not being repeated. Well, wait, I find here something very common. This down kick at 5.4 seconds. So there are more kicks here. It's not being repeated. And if I have a flue level kick at 5.4, I might find that trace at double time, which is 10.8 right here. And I can see there is also kicks repeating at 10.8. And all other shots like this up kick here is not repeating. This crazy noise is an up kick here, big one. I'm very close to this other kick here. Not exactly the same, but very close. That might confuse me, but there is no up kick on the blue line. So this is not from the well. And even more, if I try to overlay the wellbore, and that acoustic velocity makes sense for what I'm used to seeing these wells. So I know I'm looking at right now a deeper portion of the well, which actually not the well, it's just echoes from the acoustic trace because the well ends here. So I shouldn't be concerned about all these noises that are not being repeated shot after shot. So pretty much on these three fluid levels, we have a liquid level kick and a repeat at the liquid level at 5.4 and 10.8. So all the software selection is run. I need to modify that, put it in the right place. It's a good time to say, oh, well, I don't need those shots anymore. Or I will just say clear all and focus on the liquid level selection because now I know the liquid level is right here. Then I will jump into what method I'm going to use to analyze this well and get a better acoustic velocity and so on. So this selection might be there. I click on fine tune, liquid level, and make it even better selection. You see how can I drag it, or I can just use it. Most of the time I just use the mouse pointer. It's much easier. Like right there. And let's see what the software thought. So that's the software selection. That's it. When you click on reset, the software will automatically select what thinks is the fluid level. And it's right there, 5.5. Okay, let's keep going on the presentation. And we talked about that. And let's move on now to the plot control. These plot controls will be focused on how to navigate even more with more details in the main plot. And we can have an option for the echo zoom. It will adjust the acoustic trace to a scale where we can see the shot, and no matter what selection we have, it will focus on from the shot to the liquid level kick, and it will adjust the scale or the millivolt scale to see the liquid level kick completely. And let's do that here. If I click on plot controls and echo zoom, you will see the white area change to show the shot and the fluid level kick, and it will scale up to a different portion so we can focus on that portion of the trace. So we have one more option here, which is the zoom all. And when we click on zoom all, it's just what it is it will show the full trace and with the full amplitude. Probably after clicking on zoom all, you will need to scale up because it will actually show the liquid level, probably the shot kick. So I will click on zoom all. And when you click on zoom all, let me close this out. You will see the acoustic trace is not that visible. So you can click on scale up until you see better. That's when you want to see the full trace. So more options there are select region. This is a very useful one. So let's say you want to focus on a specific area of the trace. So I want to see here, it's like I want to zoom in to this specific portion. So you go to click on select, and once you do that, the mouse pointer will become into a selector. So you can kind of drag your mouse pointer, and once you release the pointer here, after selecting this, I represented that with a red square. It won't look like that in your screen. And then once you do that and release the click, the click in your mouse, then the plot will look like specific area that you selected. So we can do that right here. Let's click on select, and I want to focus on this portion here. So we'll be just zooming in to whatever the area was selected. Coming back to the presentation, we have one more option, which is the pan or panoramic, where you can actually grab your acoustic trace and drag it left or right. And I want to click on zoom, echo zoom. And if you want to see a portion more to the right, you can just grab your acoustic trace and drag it. That's what pan option will enable on your acoustic trace. And if you don't like what you did, oh, I was looking at that zoom in and I want to see again, you can use the undo button. Like, you can do that and come back to the previous view. It's just some controls that will help you to navigate in the acoustic trace. Okay, let's keep going, and I already showed you the undo, and the next thing will be focusing on, once you selected the liquid level, let's see what the acoustic velocity method calculations are, which is method 1 for color count, downhole markers, or acoustic velocity. The presentation is not intended to go into the details on those methods, but let's probably cover the basics on those. So the method number 1, once you are confident on the liquid level selection, and you need to calculate an acoustic velocity to determine the liquid level depth, you have a method available, which is the default in the software, which is the color count. And most of the time, the user do not require to take any action on those liquid levels. But we don't normally require that. So most of the time you don't, but you need to be sure the software is doing a good job counting colors if that's the method you want to do. And let's say you're shooting fluid levels inside the tubing where you don't have colors to count most of the time, or color recesses, then very likely on tubing shots, the color count method is not the best one, and you need to use something else. But let's say on the regular shot, it's a casing annular shot, and you may see a very good color count, or if the software is not doing a good color count, you will know that by looking at where the C line is, and I will show you where that C line I'm talking about is. Let's look at the echo zoom. And we can see aside, if you have the method 1 selected, you have the shot line, you have the liquid level line, and you also have a Z line. And that Z line represents the last color the software was able to count. So from this point on, the software was not able to count any other colors. And if this C line may be like in the middle of the trace, like over here, then you know the color count was poor, and you might need to make a manual adjustment to the color count if you still want to use the color count method. If you don't have something else to use that would be better, like a downhole marker or a good value of gas gravity, to use the acoustic velocity method number 3. So going back to the presentation, that's what I just said. Is the C line indicates the last color counted, and in this method is also, I think it's important to highlight that the average joint length is a value that needs to be as accurate as possible when you are using the color count method. The software will actually use this value to estimate the acoustic velocity, and unfortunately we still see a lot of fluid level shots with a 31.7 as average joint length, which is a software default. You want to look at the tubing description and calculate a better average joint length if you're deciding to use a color count, because that will impact the liquid level depth calculation. Okay, the method number 2, well, let's stay here in the color count. When you click on the color count tab or button, it will display a color analysis tab. There you can see a yellow area, and that yellow area will have a plot on the bottom part of the screen where you can see the liquid level, not the liquid level, the color kicks and the selection of the software. These red lines represents the software selection of those kicks. They are used to estimate how many joints per second is the wave traveling through, and the software will do an analysis not only for this trace, but if you click on colors, all colors, the software will have a full information on the acoustic trace. But here, let's assume you don't have a good match on the color kicks and the software selection. You can also adjust this manually by either changing the area where the software is attempting to count the colors, or adjusting the separation between these dividers. So you can click also in all color to see what the software is doing, and this has been discussed before. The software will cut the trace in 2-second pieces, let's put it that way, And here you can see how many joints the software counted compared to the total joints in the well. So you will have, this well has an excellent color count, over 90%. Then if we have a good average joint length, the liquid level calculation will be very accurate. Using the method number 2, which is a downhole marker. And the downhole marker, that will depend on wellbores. Information will include different the different configurations. Like if you have a change in diameter in the tubing or in the casing or something that may create an echo back to surface different than the liquid level, as those details are important in the wellbore schematic, because the software will depend on those downhole markers either in the tubing or the casing to be selected and used to the acoustic velocity calculation. The downhole marker is a visible acoustic reflection. So some people say, it's okay, this is downhole marker. What that is? Well, a downhole marker is any kick different than the liquid level that is visual, that you can tell this kick here based on his if it's an up kick or a down kick. And you may want to review the first Ask Echometer session on direction of kicks, where it's discussed in detail what an up kick or down kick means, or how they're produced, and the different wellbore configuration that may create different kind of kicks. But the software will rely on the wellbore information and these kicks above the liquid level to be used as a downhole marker. And of course, the word description needs to be as detailed as possible to improve the chances to use downhole markers. Sometimes we know there is something in the well that we cannot relate to depth, because we don't actually know much details on the wellbore diagram. And the software will use the distance that we know or input in the wellbore schematic to the downhole marker, and the time to the downhole marker, and we'll see how to select that in a second, to calculate the acoustic velocity. And that acoustic velocity will be used to determine the liquid level depth. And when you click on downhole marker, we'll have this window, and the options available on top will be based on how much details or changes you have in the wellbore schematic. And this well, for example, we have a tubing anchor. And that tubing anchor, when we click on tubing anchor, the software will automatically drop a red line to the corresponding time, assuming the acoustic velocity is 1200 feet per second. That's just a default in the software, but once we select the downhole marker, we need to move this red line, which is the downhole marker selector, to the proper place. So if we look at here, we have a down kick close to the liquid level kick, and this is the tubing anchor. So we need to move the downhole marker line to the right, and once we do that, the software will then estimate the correct acoustic velocity, which is 1048 for this well. If you have a bigger plot here, but you can refine the marker on the bottom of the screen, so you can drag the line and move it to the proper place. We'll see some examples on that too when we cover the examples. Okay, that leaves us with one more method, which is method number 3, and wells where you don't have a color count or a good color count, where you don't have a downhole marker or a deep downhole marker that may be useful, then you are running out of options, and then you need to use a different information to calculate the acoustic velocity, and that will be the acoustic velocity method, which has some options in there. So the method uses the acoustic velocity method is used when you don't have good color counts or downhole markers, and then it allows the software to manually enter an acoustic velocity, or it allows the software to calculate the acoustic velocity based on an input of the gas gravity, or even more, a detailed gas composition. So if you have a gas chromatography or gas analysis information that is recent, that is representative for that well, you can use that information to estimate or calculate the acoustic velocity when you don't have a good color count. So again, coming back to the software, clicking on method 3, you will have this window where you have two options. One, enter the acoustic velocity. And if you want to enter that, it's probably because you know very well this well and you are familiar with the acoustic velocity in that well from previous shots. Or we see some cases where people has no information of the well, like no gas analysis, there is no color to counts, no downhole markers, but they have neighbor wells shots, and they use let's say an average neighbor wells acoustic velocity. So that's the input. So the software allows you to manually input the acoustic velocity, or we can click on compute the gas gravity, either from inputting the gas gravity or by clicking on compute gas gravity from composition, which will allow you to input the gas composition of course, that would bring from a gas chromatography or gas analysis. What the software do with this information, and I'm going to bring a slide that you probably saw before, is the software will use the pressure, measure the temperature input, and that's important to highlight that you need to input the formation temperatures, surface and bottom hole, and the gas composition or gas gravity to estimate the resulting acoustic velocity. And what the software is doing is it takes the gas gravity, and I just brought this is an acoustic velocity paper that is available on our website and in many other Ask Echometer sessions. If you have downloaded some data sets before from our website, you might find the acoustic velocity paper. And so the software will use the specific acoustic gas gravity, and then we'll use the measured pressure, the temperature, and with that information will come with an acoustic velocity for that specific condition. And that's pretty much it. So once you have selected properly the liquid level, you have analyzed the acoustic trace, and now you have selected the acoustic velocity method that better works for that well, we only need to check for the report. So on that report, and I'll be there just in a minute, on that report, we'll have some options. I will go quickly. We're running really fast. Time flies. On the report, we have options to change the well status. Like here, we can change from producing into static. Now we know if we change into static, then we will have the option to work on the static bottle hole pressure worksheet. That was discussed previously. Aside changing the status, you can also click on settings. If you want to customize your report, you can put your company logo here and your company information here in the footer, and that will be printed on the report. Once the report is customized, you can either print it and to just put it on paper, or you can do a PDF report and you save it anywhere in your computer, or you can, if you have an email software by default in your computer, you can just click on email, and the software, like in this case, I have Outlook, will be automatically attached that liquid level report on that email. The report information probably was discussed previously, and we have the production information, casing pressure. On the very top, we have actually the well name and the date and time, the liquid level, depth, and the pump submergency, like gas-free and gas liquid submergency. We have casing pressure, the calculation of the gas flow in the annulus, how much liquid is above the pump and below the pump. That's a percentage calculated by the software. A reference for the pump intake and the formation depth, and the bottle hole pressure calculations, like pump intake pressure, producing bottle hole pressure, and this is just an input at the previous static bottle hole pressure in that well. On the lower part of the report, this is just a producing liquid level report. We have which method was used to analyze the liquid level. And what marker was, in this case, we used a downhole marker. So the marker used was a tubing anchor, and this is the depth of the marker. And the acoustic velocity resulting from that analysis. And on the right, we have the casing pressure buildup, and its details that you can also find in the pressure tab. And some comments here that you may input when you shoot the well. And I think that's all I have for the presentation. I guess we have some questions.
Thank you, Gustavo. That was probably the most thorough explanation of the TAM Liquid Level Features we've had. So I learned some things, so that was excellent job. We have just a couple of things. If you would open up your TAM software, that would probably be easiest. That way you could go directly to the question. So in the details button, so if you'll go click on your details button, the pulse type explosion, the shot path, casing, and the well state of producing. The question was, are those the defaults if you don't change them?
Yes, I guess so. When you shoot a fluid level, the defaults are what's shown right now on the screen. This will be an explosion pulse, a casing shot, and a producing well. That's probably the most common fluid level shots overall.
All right, thank you. Now, if you will open the collar count, method 1.
Okay, and let me grab just a different well. It has a better color count. This was terrible. Okay, color count.
The question was, how is the yellow band selected if you're doing a manual analysis?
Oh, okay, good question. The yellow band, let's first talk about the yellow band. Is 1 second by default, and the software will determine which is the best selection. If you don't agree with the software selection or match on the color kicks, you may change either by it's very simple in the software. Just click and drag it. You may actually expand the amount of size, but probably if you expand it, you're not actually changing anything. But if you change the separation on those kicks or those dividers, once you do that, the software will automatically switch into the manual mode. And you may play with this as you feel comfortable with, and you might find a better area. This one is very good, but if you're not happy with that and say, oh, I screwed this calculation, you can always come back to the auto color selection. So you can play with that freely and then come back to the auto color selection.
Gustavo, there's this at the bottom. It says interval acoustic velocity and average acoustic velocity. Can you explain the difference?
Yes, that was a good question. I probably will solve a lot of questions for people here. So the interval acoustic velocity will be focused on only this portion and will be based on this second of data. So the software is actually counting 16.47 joints per second, and that will be referred to this interval that we're analyzing here. But the software doesn't only do that. The software actually analyzes all the trays, and with the software, I will click on all colors. So when we click on all colors, the software is actually looking and counting colors. These vertical lines are color being counted by the software, and then the software each 2 seconds will have an average joint per second. So the software then will take an overall average, and that will be this well 16.66, which is the same value on the previous window, and 16.66 times the average joint length will give us an average acoustic velocity. So this interval acoustic velocity will be referred only to this. That will be 16.47 times average joint length, or using the average joint length. And then this will be the overall average acoustic velocity.
All right, we have another question that just came up, still regarding the collar count and counting collars, and it's, how do you manually select the right interval if the C line is less than 70%? Is the band that gives the highest number of colors, the one that the software chooses.
Yeah, this was a good color count. So we see the C line is really close to the liquid level, so we probably won't see any improvement. If we try to adjust the selection, the color selection, we see slight changes on the acoustic velocity here if we manually intervene and try to do a better job than the software already did. But yes, you will change the yellow band and probably want to adjust the color count or color selection until you have a C line that goes the deepest, or you can see how many colors are you counting by that. But yes, focusing on the C line, moving more to the right, that should represent a better result for you. And you can always confirm the color percentage right here, joints counted versus the total amount of joints.
Okay, one more about the color count from Nathan. On the color count, when clicking all colors, the time to the first color is greater than 0.3 seconds. Review the liquid level. How do you fix this?
Okay, that's this example is not very good for that, and because we're counting colors from very soon in this well, and we see this. Remember, this is 4 seconds, and the time to the first color is 0.28. But when you shoot a well with a huge amount of energy, and the software kind of the microphone will be muted when the shot is so high, when there's so much energy hitting or impacting the microphone. And we'll start counting colors deeper. So how do you fix this is, well, if you already did the shot, there's no way you can fix that because you didn't record data and that shot. But if you're at the well, what you can do, and very likely will work, is you use a smaller amount of pressure on the shot. So the differential pressure between the gun and the well will be less or lower, and then you will very likely count colors much sooner. So use less differential pressure is a short answer. Use less pressure.
Right, super. You talked about the zero offset. You mentioned that the zero offset is important for transducer data and for the shots. What other results might be seen, and what does that mean? So I guess just getting different zero offsets.
Or what other results you may get? Well, I don't know if I fully understand the question, but you want to do a zero offset before the shot, just to know that your pressure transducer is working properly. That's probably the first thing you realize when you're doing that. If you're using a wired equipment, you will check not only the pressure transducer, but also the connections. Sometimes you just forget to connect the cable, and by performing a zero offset before the shot, you're ensuring you have the proper connection. You're not reading pressure from the well. You're letting the software know what the zero offset is, and you're ensuring a good communication. And if your pressure transducer is giving you a bad signal, is out of calibration, and you will catch that during the zero offset too.
Lots of times if you are zeroing your pressure transducer at different times during the day, it's different temperatures outside. And so the temperature does have an effect. And we've seen zero offsets. If your zero offset is +1 or 2 or -10, as long as it's within a reasonable range, and you want to look from the last time you checked that zero offset to this date, and you want to be sure and keep comparing those. You're looking for a big change in the zero offset. You're looking for a possible drift. So you mentioned in the comment, Melina, if you have a zero offset of 1 or 2 or 0.1, and that's fine. That's what you want to see. Until you start seeing a really big drift, that's kind of what you're looking for. But as far as how can it be solved, if you have a really high offset, then you might want to send your transducer or your gun, if you're using wireless equipment, in for us to possibly recalibrate.
That's a good point. You can track just by looking at your previous offsets. You may see when the pressure transducer may be out of calibration. While you were answering, Karian, I was reading one question. Probably it's a single question I have read on the chat. I just opened the chat, and that's from Lupe, asking for if the casing pressure fluctuates, and where would the build-up line need to be chosen. So I think it's a good time to choose to show one well, which a lot of people is familiar with, is the average well. That's in the example folder that you have installed by default in the TAM or the TWM. It's an old data set, but I like that example to show the impact of selecting a good casing pressure buildup. I'm going to span the casing pressure buildup, and we'll see the software is doing by default. So it goes from the beginning of the casing buildup tab to the last point. And simultaneously, I'm going to open the report. I just want to focus on here on the liquid level, on the liquid percentage. Right now, the calculation based on this change in pressure and time is 38%. But we can see how the points are not aligned to the line. So we're jumping all over the place. And some people may last the test run for 1 minute or for 2 minutes, or some people just are in a hurry and just collect one data point and they think this is enough and they remove it. So we're going to I'll try to keep this on the side so you can partially see the liquid percentage above the pump while I modify this. So I will click on the left and we'll see how to changing the point to that line. The slope will be affecting the liquid percentage calculation. And let's say this guy was in a hurry and only let the well run for 15 seconds and stop the test and say, well, I have a lot of liquid in the tubing and my submergency, my gas-free pump submergency is 1750 feet. So I have a lot of pump submergency. But if they could wait just for 15 more seconds, so stopping the test right here, that liquid percentage will drop dramatically, and then we lost 1,000 feet at pump submergency just by that. So specifically on these cases, when you see the pressure points are jumping all over the place, you want to wait more time. You want to select a more representative acoustic casing pressure buildup. Like, unfortunately, on this one, we have only one shot, and that's another reason to have several shots to select. And I think I already showed this other well. We had the run pressure buildup selected, and probably you don't want to use this one, but you get your second shot and use this for the report and the calculations on the liquid percentage. I hope that clarifies Lopez's questions. So when do you want to stop the test? Well, when you feel comfortable with the pressure buildup and it's actually representative, it's not jumping all over the place. Having this jumpy pressure might be due to a leak on the wellhead, on the connections, on the gun, or due to out of calibration pressure transducer. Might be several reasons.
We have a question from Mark. He says when he's using his laptop in the field, when he opens the Edit tab on the Pick Well window, the Save and Close buttons are off the screen, and I can't edit the equipment in the field. How can I get these displayed?
That's probably it's a screen resolution problem that may be fixed. It's not a software-related problem. It's more a resolution problem that you might need to change. If you please can get the Mark's information and we can help him offline to solve this. Especially Windows 10 some versions of Windows 10 may give us some headache on plotting.
And there's another comment from Robert that's sort of on those same lines. He says when he puts his logo on the report, it's disproportionately small. Is there a way to increase the size of the logo on the report?
That very likely has to do with the size of the image, the pixels, or just the size of the image. Try to just probably copy that logo from a different place, and it's just really small.
All right, that is all of the questions that we have so far. Okay,
well, I have some kind of interesting well fluid level shots that I want to show, and yeah, just let me jump in there, and let's start with here. Is a liquid level low or high? And we already saw this one. Let's check this flue level. So for the people who's used to the flue levels, and we'll try to use what we have learned, play a little bit with the data. And this, of course, seems like too big, and so we scale down. We say, well, there's a very likely a liquid level kick here, but I see a noise in here. So what is this? Probably I want to filter the data and try to apply the low pass filter. I say, well, that disappeared, just a high frequency noise, probably not something coming from the well. Scale up a little bit. I don't see much there, and that's okay. Well, the liquid level selection looks very good, and I may expand or use the plot control to zoom all, and then increase that. So that's a liquid level kick. That should be the echo of the liquid level. And if we just stay like that, this looks like a very good selection. And the color count is beautiful. I mean, this is very close to the liquid level. But something we need to consider is you always want to have a look at all the trays. And if you look at another flue level shot on this well, it's very similar. Liquid level selected properly. They will all look the same. So I will just stick to the last shot. And I will check on the liquid level selection from the software. So if I click on fine tune and liquid level, I will ask the software by clicking on reset, what do you think is the flue level? Where do you think is the flue level at? And the software selects that kick over there, and I will remove the low pass filter. I'll do that this again because we will have some changes when you apply or not the low pass filter and reset the data. So that's a very good selection. So that's a software default selection of the liquid level. But we know, if you remember how the acoustic wave behaves, if the liquid level is at 9.7 seconds, then the second round trip travel time will be at 19.4, about that. So if we use a reference line, I will put a 19.4. Well, actually, I don't have even 19.4 in the plot. It wasn't recorded. So this kick here is 17.4, which is 8.7 double time. So the liquid level is not at 8.7. So what it tells us is, well, this kick is not an echo of this kick. If we review the well, say, well, hold on, and we might need to review the wellbore schematic because we missed to input some data, and we see we have a liner at 93.45. And what's actually happening here is this kick is actually a top of a liner, and by not inputting the right information in the wellbore schematic, I might be doing a really bad liquid level selection, which will lead to a huge pump submergency, which is not right. So I will come to the wellbore schematic and I will fix that because that is wrong. So I will input that liner, and that's a 5.5 liner according to the information was available but not input. And I will save that. And now the software, well, I think I did it wrong. I hit the wrong information. And that is 5240. I'm sorry for that. So the 578 casing runs down to 5240. Okay. And that's 5240. And now, okay, now it matches. So the casing has a change in diameter. It's a down kick due to the decrease in the area. Now this is the liquid level. No, this is not the liquid level. The liquid level is right here. So I could either move it there or I could use the next button to put it right there. Liquid level is properly selected now. Let's pick another well to analyze. This reduction aligner is a good example on how important it is to input the information, a detailed wellbore schematic. And I want to focus on this area here, so we'll click on plot and the software. Let's check at the liquid level. I will reset this. The software is selecting 8.9 kick as the liquid level, and I think the software is wrong. But by looking at the wellbore schematic, I see, well, this kick is coming from the top of the liner. And there is an up kick here I want to check another shot if it's as present there. Well, yeah, I have an up kick, and that matches to a tubing change in diameter. So the up kick matches to the tubing change in diameter, the down kick matches to the top of casing, and the liquid level should be here. And I see the regular behavior at down, down, up for a top liner. One more thing is the top liner has a bigger kick than the liquid level. So not always the liquid level is the biggest kick. Many lessons we can learn from this well. And I will just, I can manually select it, or I can just click on next and let the software to select that for me. I will fold the trace as we did before. So the up kick matches to the down kick, and everything is looking okay now. I will unfold the trace, and then I have the proper selection. Well, if you want to know what those kicks are, you have the drawing, or you can input a note and say tubing change in diameter, and so on. And that's a top liner, and this is a top liner repeat. Those are just quick notes. You can print this information, and if I click on the report right now, I will show the second. On the report, you will have numbers 1 and 2, and if you go to the second page, those will be the notes on the trace. Number 1 is a tubing change, and the top of liner repeat, I should say repeat. Okay. Now let's get to another well where this kick is not clear. Well, let's see what that is. Well, this is a flue level shot, and there is not an obvious liquid level. As you can see, I'm plotting the whole trace, so nothing is hidden. I will check the previous shot, and the software has done a different selection. And well, I'm not sure what the software is selecting right now. I think it's wrong. The next flue level shot, there is something close to 8, but I see something else here around 18, 19 seconds. We could continue looking at all the shots, and now we have a shot that the down kick at 19 seconds looks the biggest one. So I'm not sure where the liquid level kick is at, because I have different information from flue level shots. So something that you will probably do in this well is overlaying the shots and try to see how consistent are those kicks at that specific time. So clicking on annotations and shots preview, we have this big table, and we can expand it. And I will just click on overlay and overlay, and I will do that as I haven't analyzed that by acoustic velocity yet. I will do the time. So by overlaying those shots, and that's for the maximum overlays that I can do, that's 5. I will spread that out. That's probably too much for you. You can select just a couple of traces. Just for this example, I would like to do them all. So one more thing I want is, so we can follow up, is to put the depth reference line. So there is some kicks that are being repeated. So I was confused in one of the liquid level shots at 12 seconds, but that's actually, no, it's not a kick that's repeating. It's only there, it's not here. And it's very constant on all the shots have this down kick at 19.1, let's say. So the liquid level is down there. So if I want to overlay the wellbore schematic, and I will put it a little darker, and probably want to remove some of the traces. I want to remove some of the traces so we can see better. So the liquid level is really close to the pump. And one of the comments was that, well, the well is pumped off. Unfortunately, we don't have a dyno card to confirm that information, but there was a comment on the well being pumped off. So this matches with the information we're reading at. And the color count for this shot was bad, and you may want to use a different method to calculate the acoustic velocity. Let me jump to another example, and that's when you have a shallow liquid level. This is a acoustic trace as we receive it, and we're not plotting all the trace. Well, we don't need to focus below the end of the wellbore. And I'll do that and scale down, and I'll see the liquid level is at 0.8, which is the software selection. And that doesn't seem to be right. So the software did a wrong selection, and I will check liquid level at reset, and yes, that's what the software did. If I move this selector and I click on reset, the software will tell me his selection. Well, I don't agree with that software because I know the liquid level key based on the time difference is right here. So I will move either from here, I could use that, or I could use the next button. The software will not automatically pick the first key. If you keep trying, the software will not read anything below or that zone close to the liquid level shot. So we'll drag this, we'll put it kind of over there, go back into the liquid level, and I can even zoom in this more. I will click where I want this. So this key will be right there. That's a liquid level key. What software, what method will be used? Well, let's try to use a color count. Well, in 1 second, we actually have 2 liquid level kicks. But if we can focus on this area just before the liquid level, and we can try to increase the scale, we can see some kicks here, kick, that we might use to select, like that one, and I'm pushing the software really hard here. Just let me. It's hard to get these colors. Let me try different filters. It's gonna be tough. Well, this is gonna be easier. I will pick the bottom part, and bottom part, and that might be an acoustic, very bad acoustic velocity, but about 1,200 feet per second.
Gustavo, on this well, you might try the high bandpass because you have a lot of echoes.
Shot.
You have high bandpass color count. You know, if you go back to that,
Yeah.
go back, you can
Yeah,
the
that
color
will
filter.
work better.
That
That's
will
correct.
work better.
That will work better.
Yeah, so just that takes out the noise between the colors. So if you scale it up and hit the high bandpass,
here.
yeah, it should be better.
Like there, that'll be better. You see this kick here, this kick here, this kick here, and probably we can fix this other kick here.
Anyway, it's hard.
It's hard. Anyway, the well is full. The flow level is really shallow. It won't probably change any decision on the well. Okay, one more well is it's very shallow. Let's see this very shallow liquid level, which we couldn't see at the beginning. It will have the shot, and well, there's not obvious liquid level kick. The pass filter is not applied. The low pass filter, I mean. Another shot is the software is not even able to select the liquid level, so it puts a line at 8.5 seconds. We know it's too deep, and well, we actually don't see any liquid level kick. So the background noise is similar to pretty much all the trays. But we keep shooting and shooting until we started to see something, and the software wasn't able to find. You see the red line the LL is now a red line because the software is unable to find the liquid level and says auto liquid level detection failed. So manually relocate the liquid level marker. But I still don't know where the liquid level is at. And I see this trace here is different than what I used to see. But the next shot will clarify that. So the liquid level is actually up here. I will get closer to that area. I may use the flow control and select. I will focus on this. And I see a kick. Well, I think I found the flow level. But after having the well shut in for a few minutes, and we see the liquid level, we started at 153 and 9 minutes later, we were able to see the liquid level. So that's a liquid level selection right there. And we still see like 4 colors in between. So proper selection, and we see how to use the navigation. This would be a really hard shot to analyze in TWM where you don't have these navigation options. one more well before we check. We have more questions.
We have just a couple more questions.
Okay, I will check this well real quick here. And this is a liquid level shot on a well full of liquid. And again, the liquid level detection failed, and we need to manually relocate that. And this is usual when you have a liquid level on a well full of liquid. Well, when the wave travels down the liquid, and in this one, I want to just do a zoom in this area. I want to overlay the wellbore schematic on here. We say, well, this might be the liquid level, but we look at all the traces, it's down, up, but it's a normal behavior for a full of liquid well. And I'm going to use the wellbore schematic information. Like I know I have a liner and I have a packer, and the wave will travel down to the packer. And if I use a downhole marker, because I will need to just move the liquid level somewhere, I will use that to enable the downhole marker. I will do that, and what I'm doing is selecting the downhole marker, and I have an acoustic velocity in the liquid of 4,540 feet per second. Or I could use, I will keep it like this. I will use the other shot to use not the top liner, but I will use the packer depth. So here I won't select the liner, but the packer. I will put the red line on the packer, kick, and this is pretty much the same acoustic velocity. So that's acoustic velocity in the liquid for that specific well, which is pretty neat to see. The well is full, but we can still see some things in there. And the liquid level is just on surface, is really, really high. And this is another well. It's more, let's say, more normal to see. Down kick, up kicks. Again, it's a well full of liquid. We can do the same. Use a downhole marker. Select the kick from the packer, and that's what we're selecting here. And the acoustic velocity is 4,800, almost 4,500 feet per second.
Gustavo, on this well
Yes.
here, can you turn off the low pass filter and show them how the signal looks normally?
It is off. It
is off. Okay.
Yeah, it's just too much energy there. So we have to scale down to almost 1 volt to see the trace.
Yeah. Okay. Thank you.
And yeah, the liquid level selection, if we can go there, is really close to the surface. It's just like first kick here, first kick there. It's really, it's full. It's like 10 feet from surface, not 47, because 47 is related to this acoustic velocity, will be like 1,200, will be like 10, 11 feet from surface. That's a liquid level depth. One more well was low pass filter. This one. This is an interesting one. This is the last well I'm going to review to jump into the questions. Is we receive this data and we say, well, we have this fluid level. It is a gas well. We don't think the liquid level might be too high, but when we start to analyze the data, you can show all the trace. And we have said before that, well, usually when we see this tornado shape, is usually a liquid level very high, and we apply the low pass filter, that's kind of clear now. So that seems to be a very high liquid level. Well, not always applying the low pass filter helps, but let's see. I will take this and drag it down where I can see the well. And if I unclick the low pass filter, I will focus on the beginning of the trace. Say, well, now I can see the fluid level might be there. And I apply the low pass filter and I say, well, you know what? Yes, the liquid level is right there. If you can see the kick and the time difference, this is the kick from the liquid level. I'll say, well, that's right. Now we have a low pressure and the well is full of liquid, and now they found the liquid level. There is another well, and we apply apply the low-pass filter. And this one, it helped a lot. But let's check. This is other well, and we have pretty much the same. We expand, we see this tornado shape. This might be, well, this is a very high liquid level now. But by using the navigation tools, we will focus on this very early portion of the trace, and we see actually this is an up kick. The first kick is an up kick. And then we have an up kick and a down kick and up and down, and we're familiar with a hole shape. Well, if that's a hole, is it possible that the liquid level may be here? Well, we have over 4,000, almost 5,000 psi. So there's no way that this well with 5,000 psi is a gas well might have such a high liquid level. That would result in extremely high downhole pressure, which is not true. So we don't know where the liquid level is at. Well, if you have the liquid, the bandpass filter, the low pass filter applied, you won't see anything. But if we remove the low pass filter, we see the trace is coming down, and I'm going to close this a little bit more, and we see something change here. This is coming down normal, and something that the wave changed at that point. So we'll check another shot and do the same. The low pass filter is applied, tornado shape. Well, not necessarily high liquid level, and we will zoom in this area and see something happen here. Well, this echo from the hole, and then the down kick right here is the liquid level kick. So I will change what the software is thinking, and I will say the liquid level is at 6.1.
I agree.
If you want to focus on the beginning of the shot, you will see an up kick and a down kick, and the first kick represents a hole. They were not expecting that, but they couldn't realize where the fluid level was. It was kind of, but they normally apply the low pass filter for the analysis, and by applying the low pass filter, actually, it doesn't help on this one. Well, I think we're 5 minutes away from 2 hours, and I'm going to stop here. I've had a few more examples, but let's jump into the questions.
That was a really neat example. Up on the liquid level history button in the upper right-hand corner, we had someone that was looking for their tubing pressure column.
Okay.
Okay. And then the question is, where can the tubing pressure be entered? He's used to entering the tubing pressure in TWM and doesn't know where to enter it in TAM.
I think we don't have a field to enter, but when you're doing dynamometers, and I need to find a well with the dynamometer, you can input the tubing pressure when you're doing a dynamometer, and I want to use the average well. And here, when you're in the dynamometer analysis or details, sorry, you can input the tubing pressure, but I don't think we have a field for the tubing pressure for the liquid level shots that's spanned into the.
So Gustavo, if you have your gas gun attached to the tubing and you shoot down the tubing, then if you go back to that gas well that you just looked at, is the tubing pressure there on that screen in the tubing pressure column because the gas gun is attached to the tubing?
Correct. The tubing pressure will be measured. That's
right. So if you shoot down the tubing column will have tubing pressure in it. If you shoot down the casing column will have the casing pressure in it from the fluid level shot. So now if you look at the liquid level history, now if you look at the liquid level history now, it's going to show the tubing pressure.
I need to enable the tubing pressure because the shot were done through the tubing.
Right. So you can see which shots are taken down the tubing.
It's not an input, but it's measured. That's correct.
Right. So there's now the data is either in the tubing column or the casing column, depending upon where the gun was attached and the fluid level was shot.
Okay. And then the second question, back to the collar count. What is the difference in the collar count button filters, the raw, high pass, band pass, high band pass?
Okay, that's a different processing of the data that when it's recorded to try to show you're not actually changing anything on the trace. You're not modifying the calculations. You're just changing the way you look at the data to be able to properly select the colors. Like we used a high bandpass on that very shallow liquid level, but we're using a bandpass right now, or we use a high pass filter, and all, the only thing that it's doing is changing the way it shows the data to you, so you can have a better options to properly select the liquid level kicks.
All right, well, that looks like all of the questions that we have. Gustavo, thank you very much for a very informative session. I guess, do you have any other comments? Or
no, probably it's a lot of information to process, and hopefully not only new users but also experienced users found some new features in TAM that maybe, help them to analyze the wells in the future. That's the main purpose.
All right, well, we sure appreciate you all joining us today, and we appreciate your time and the excellent questions and feedback and comments. And if you have any follow-up questions or comments, we always welcome those. So we hope you have a wonderful weekend and hope to see you next Wednesday. Thank you so much.
All right, thank you.